Hey folks, I'm Jen Foxbot and welcome to MakerQuest. In this episode, I'm going to cover Faraday cages. A Faraday cage is made of a conductive material, like metal, and it blocks out external electric charges and electromagnetic radiation, like radio waves, microwaves, and visible light. Okay, so how do Faraday cages actually work? Well, you can think of a Faraday cage like a hollow conductor, in which the charges stay only on the outside of the structure. So if you approach a Faraday cage with an externally charged particle, that particle will generate an electric field. And the charged particles within the conductor of the Faraday cage will respond to that electric field by reorienting themselves within the conductor. So for example, if you have an externally charged particle that's positive, the electrons in the conductor will be attracted towards that charged particle, and they'll move towards it. So then effectively you get positively charged particles on this side, negatively charged particles on that side, which will set up an internal electric field in the Faraday cage that is equal and opposite to the electric field generated by the charge on the outside. So, in the presence of an external electric field, the net result is that the electric field of the Faraday cage is effectively zero. So even though there's no charge on the inside of the Faraday cage, the interior is effectively shielded from static electric charges on the outside, as well as any external electromagnetic radiation like radio waves and microwaves. So how do you build one? Well, it's as simple as wrapping your head in tinfoil. Ta-da! No, just kidding. That's probably overkill. There's not been any evidence that radio waves are harmful to our bodies at all. But there are actually tons of practical applications for Faraday cages. Like I mentioned before, you can use them to shield your electronic projects or your science experiments. You can also use them to demonstrate cool science experiments with Tesla coils. Or you can use them to protect some of your projects or buildings from lightning strikes, which is always good. So to build a Faraday cage, you just need a conductive material. You want to use something with low resistance, like aluminum or copper. And then you essentially just make a metal cage. So the gap size or mesh size of your cage will determine the wavelength of electromagnetic radiation that you can block out. So basically, if your gap size is smaller than the wavelength of the electromagnetic radiation, it will effectively block out that electromagnetic radiation. Alright, so I'll leave it there for now, and I will leave you with a question to ponder, and that is, what happens if you ground a Faraday cage? So think about that, and stay tuned to the next episode to find out an answer. And to answer last week's question, I asked, how do you increase the magnetic field of a solenoid? Well, first of all, it helps to know how to calculate the magnetic field of a solenoid. And that equation is B, which is the magnetic field, equals mu naught times N times I. In this case, mu naught is a constant, N is the number of turns in your coil that make up the solenoid, and I is the current flowing through the solenoid. So, since mu naught is a constant, we can't really do anything about that. But N tells us that we can add more turns to our solenoid, which will increase the magnetic field, or we can also increase the amount of current flowing through our solenoid by using a larger power source. So, hope that helps. Let me know if you have any questions on either that explanation or on Faraday cages in general. So thank you for watching, and please subscribe.